Hello everyone. Today we will study random variables. First of all, let me introduce what it is. Let S be a sample space. And let X, let capital X, from S to real number. Let S from capital S to real number be a function. Which assign each sample point to a real number. So let capital S be a sample space, and let X, capital X, be a function which assigns each sample point to a real number. Then this function X is called a random variable. So a random variable is a function. It's a function X. X assign every element in a sample space to a real number. X assign every element in a sample space, that's called sample point. X assign every sample point to a real number. Next, let me show you an example. Let's consider an experiment of rolling a die. Let's consider an experiment of rolling, say, 2 dice. Consider an experiment of rolling 2 dice. Let the random variable X represent the sum of the two dice. Let the random variable X represent the sum of the two dice. Evaluate each of the following expressions. Now, when we roll 2 dice, how the sample space looks like? Let me show you a picture first. When we roll 2 dice, how the sample space looks like? When we roll 2 dice, we may get 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. That's a simple space when we roll 2 dice. That's called a simple space. Each element here is called a simple point. Each element in a simple space is called a simple point. Now, what's x of 2, 3? What's x of 2, 3? X assign every simple point to a real number. Every element here is called simple point. X assign every simple point to a real number. What's x of 2, 3? Here, x represents the sum of the 2 dice. X represents the sum of the dice. If the first die comes up 2, second die comes up with 3, the sum of the dice is 5. X represents the sum of the dice. So x assign the simple point 2, 3 to number 5. X assign the simple point 2, 3 to number 5. What's x of 1, 6? What's x of 1, 6? X assign every simple point to a real number. Here x represents the sum of the die. So 1 plus 6 is 7. X assign every simple point to a real number. Here x assign 1, 6 to number 7. How about x of 5, 3? X of 5, 3. X assign 5, 3 to number A because 5 plus 3 is A. So x assign this simple point 5, 3 to A. Next, what's the probability that x is 4? What's the probability that x is 4? Here, since x represents the sum of the dice, when x is 4, that means the sum of the dice is 4. When the sum of the dice is 4, we have 1, 3, 2, 2, 3, 1. So we have 3 favorable outcomes. When the sum of the dice is 4, we have 3 favorable outcomes. We have 3 favorable outcomes over 36 total possible outcomes. So the chance is, probability is 3 over 36. We have 3 favorable outcomes over a total of 36 all possible outcomes. When x is 4, the number of favorable outcomes is 1, 2, 3, 1, 3, 2, 2, 3, 1. Together is 4. Their sum is 4. We have 3 favorable outcomes over a total of 36 all possible outcomes. What's the probability that s equal to A? What's the probability that s equal to A? X represents the sum of the dice. When the sum of the dice is A, we have 2, 6, 3, 5, 4, 4, 5, 3, 6, 2, 1, 2, 3, 4, 5. We have 5 favorable outcomes over a total of 36 all possible outcomes. We have 5 favorable outcomes over a total of 36 all possible outcomes. So that's 5 over 36. What's the probability that s is equal to 12? X represents the sum of the dice. When the sum of the dice is 12, we only have 1 favorable outcome. That's an only one feasible outcome over the total of 36 all possible outcomes. That's 1 over 36. Next, what's the probability that s equal to 1? What's the probability that s equal to 1? X represents the sum of the dice. Here, none of the sample point has x. For none of the sample point, s is 1. The sum of every pair here is not 1. So, none of them has x equal to 1. None of the sample point has s equal to 1. So that's impossible. Since none of the sample point has s equal to 1, we have 0 feasible outcome over 36 all possible outcomes, which is 0. Because for none of the sample point, x is 1. So we have 0 over 36. 0 feasible outcome over 36 all possible outcomes. That's 0. What's the probability that x less or equal to 5? What's the probability that x less or equal to 5? X represents the sum of the dice. When the sum of the dice less or equal to 5, here we have 1 plus 1 is 2. That's less than 5. 1 plus 2 is 3. 3 is less than 5. That's okay. 1 plus 3 is 4. 4 is less than 5. That's okay. 1 plus 4 is 5. 5 by itself is less or equal to 5. That's okay. Then 1 plus 5 is too big. Second row, 2 plus 1 is 3. 3 is less than 5. 2 plus 2 is 4. 4 is less than 5. 2 plus 3 is 5. 5 is less or equal to 5. That's okay. Next number, 2 plus 4 is too big. 3 plus 1 is 4. 4 is less than 5. 3 plus 2 is 5. 5 is okay. 3 plus 3 is 6. That's too big. Next row, 4 plus 1 is 5. That's okay. 4 plus 2 is too big. 5 plus 1 is too big. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 feasible outcomes over a total of 36 all possible outcomes. We have 10 feasible outcomes over a total of 36 all possible outcomes. So probability that x less or equal to 5 is 10 over 36. Next example. Consider the experiment of flipping a coin 4 times. Consider the experiment of flipping a coin 4 times. Let the random variable x represent the number of heads Let the random variable x represent the number of heads. Evaluate each of the following expressions. So let me draw a simple space first. Going 4 coin, let me draw the simple space first. For 4 coins, we can consider 2 coins at a time. For 4 coins, we can consider 2 coins at a time. For the first and the second coin, for the first and the second coin, there are 4 possible outcomes. It could be head, 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 tail, tail, head, tail, tail. For the first and the second coin, there are 4 possible outcomes. For the third and the fourth coin, for the third and the fourth coin together, there are 4 possible outcomes. It could be head, 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 tail, tail, head, or tail, tail. Then together, head, 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 head. First two coins are heads. Last 2 coins, third and the fourth coin are heads. Head, 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 tail. Head, head, tail, head. Head, head, tail, tail. Head, tail, head, head. Head, tail, head, tail. Head, tail, tail, head. Head, tail, tail, tail. Tail, head, head, head. Tail, head, head, tail. Tail, head, tail, head. Tail, head, tail, tail. Tail, tail, head, head. Tail, tail, head, tail. Tail, 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 head. Tail, 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 tail. That's the simple space when we flip 4 coins. That's the simple space. That's the simple space S when we flip 4 coins. Now, evaluate each of the following expression. What's x of head? What's x of tail, head, head, head? What's x of tail, head, head, head? X represents number of heads. Here we have 3 heads. So x of tail, head, head, head equal to 3. What's x of tail, tail, head, tail? X represents number of heads. Here we have only 1 head. So x of tail, tail, head, tail is 1. What's x of tail, 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 tail? X represents number of heads. Here there's no head, so x is 0. So x assign this sample point to number 3. X assign this sample point to number 1. X assign this sample point to number 0. X assign every sample point to a real number. Now, probability. What's the probability that s is equal to 2? What's the probability that s equal to 2? X represents the number of heads. So here, for this sample point, x is 2. For this sample point here, s is 2. For this sample point, s is 2. S is 2. S is 2. S is 2. So for this 6 sample point, s is 2. So probability that s equal to 2 is 6 out of 16. For this sample points, x is 2. So probability s equal to 2 is 6 out of 16. What's the probability that s equal to 3? What's the probability that s equal to 3? X represents number of heads. So for this sample point here, for this sample point here, x is 3. X represents number of heads. For this sample point, x is 3. For this sample point here, x is 3. For this sample point, x is 3. And for this sample point here, x is 3. X represents number of heads. So x equals 3. 1, 2, 3, 4. There are 4 outcomes, x is 3. For 4 of the sample points, x is 3, which is 4 out of a total of 16. What's the probability that x equal to 4? X represents number of heads. So probability that x equal to 4 is only this outcome. Only this outcome has s equal to 4. Only this outcome has s equal to 4. Probability that s equal to 4, s represents number of heads. Only this outcome has s equal to 4. So the probability is 1 out of 16. What's the probability that s equal to 5? X represents number of heads. None of an outcome here has 5 heads. None of an outcome has 5 heads. So probability that s equal to 5 is impossible. That's 0 out of 16, which is 0. None of an outcome has 5 heads. So none of them has s equal to 5. None of them has s equal to 5. That's impossible. Probability is 0. What's the probability that s greater than 2? If s is greater than 2, s could be either 3 or 4. If s is greater than 2, s could be either 3 or 4. When there are 4 heads, s is 4. When there are 3 heads, s is 3. X is 3. S is 3. X is 3. So when there are 4 heads, s is 4. When there are 3 heads, s is 3. Together we have 1, 2, 3, 4, 5. There are totally 5 outcomes. 5 out of 16. 5 favorable outcomes out of 16 all possible outcomes. It's 5 over 16. Next, in examples 1 and 2, in examples 1 and 2, find the sets of all possible values of x. In example 1 and 2, find the sets of all possible values of x. In example 1, x represents the sum of the die. So s could be 2, 3, 4, 5, 6, 7. Here s is 8. S could be 9, 10, 11, at most 12. So s could be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The rest repeats these values. For this here, s is 3, 4, 5. The rest repeats these values. So s could be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in example 1, s could be 2, 3, 4, 5, up to 11, 12. That's the set of all possible outcomes of x. In example 2, what's the set of all possible values? X represent, in example 2, x represents the number of heads. So here, for this outcome, s is 0. There are 0 heads here. For this outcome, S is 1. There's only one head here. This is also 1. This outcome S is also 1. For this outcome, S is 2. For this outcome here, S is 3. So S is 1. For this outcome here, S is 3. And for this outcome here, S is 4. X represents number of heads, so we may have 0 head, 1 head, 2 head, 3 head, at most 4 heads. We may have 0 head, 1 head, 2 head, 3 head, 4 head, at most 4 heads. We won't have more than 4 heads. So in example 2, S could be 0, 1, 2, 3, 4. That's the set of all possible outcomes S could be. In example 1, X represents the sum of the dice. It could be 2, 3, 4, 5, up to 12. The sum of the dice could be at most 12. The sum of 2 dice could be at most 12. In example 2, X represents the number of heads. When we flip 4 coins, we can have 0 head, 1 head, 2 head, 3 head, at most 4 head. We won't get more than 4 heads. So that's the set of all possible outcomes of X. Next, let me introduce support. What does support means? Let X be a random variable. The set of all possible values of X. The set of all possible values of X. It's called the support of X. Denoted by SUPP of X. This represents support of X. SUPP of X. So, in example 1, support of X is in example 1, the set of all possible X is 2, 3, 4, 5, up to 12. The set of all possible value of X is 2, 3, 4, and so on, until 11, 12. That's support of X. And in example 2, support of X. In example 2, support of X is 0, 1, 2, 3, 4. The set of all possible X. The set of all possible value of X. 0, 1, 2, 3, 4. Note. If A doesn't belong to support of X. If A doesn't belong to support of X, then for any real number A, if A doesn't belong to support of X, then probability that S equal to A is 0. If A doesn't belong to support of X, for any real number A, if A doesn't belong to support of X, then probability of S equal to A is 0. Because support of X represents a set of all possible X value. If X doesn't belong to support of X, X cannot be A, This is an impossible. This is an impossible value of x. This is an impossible value of x. That's why its probability is 0. For example, in example 2, number 5 doesn't belong to the support. In example 2, number 5 doesn't belong to the support. That's an impossible value for x. This is an impossible value for x. Number 5 doesn't belong to the support of x. Its probability must be 0. And in example 1, number 1 doesn't belong to the support. In example 1, number 1 doesn't belong to the support. That's an impossible value of x. So probability of s equal to 1 is 0. That's what it says here. If for any real number, if it doesn't belong to the support of x, then probability of s equal to a is always 0. For any real number a, if a doesn't belong to the support, then probability that s equal to a is always 0. Next, if support of x is countable, then we say x is a discrete random variable. Then we say x, the random variable x, is a discrete random variable. If support of x is countable, then we say the random variable x is a discrete random variable. What does the word countable means? Countable means there's a way we can count all elements. There's a way we can count all elements. It's called countable. For example, 2, 3, 4, 5. There's a way we can count all elements. That's called countable set. For example, the interval 1, 2, 3, 4, 5. This is countable. I'm able to count all elements. If I go this way down, I can count all the numbers. This is countable. For example, 2, 4, 6, 8, 10. In each set, I can count 2, 4, 6, 8, 10. There's a way. If there's a way I can count all elements, this set is countable set. For example, 1, a half, a third, a 4, a fifth, and so on. I can count this way: 1, a half, 1/3, 1/4. If there's a way I can count all elements, this set is called countable set. So those are countable sets. Then what's uncountable set? What's uncountable set? For example, the interval from 0 to 1. The interval from 0 to 1, this set is uncountable. If you try to count what's the first element in the set, what's the second element in the set, there's no way we can count all elements. There's no way we can count all elements. This is uncountable. The interval is uncountable. This is an uncountable set. Another example, from negative infinity to infinity. This is uncountable set. This is uncountable set. There's no way we can count all numbers from negative infinity to infinity. Those are uncountable sets. So if I can count all elements, if I can count all elements in a set, this is called countable set. But if I'm not able to count all elements, in a set, that's called uncountable set. In general, intervals are uncountable set. Intervals in general are uncountable set. If I can write down the set, then the set, of course, the set is countable. If I can write down all elements of the set is countable. If I can write down all elements in the set, then the set is countable. So if the support of x is countable, then we say the random variable x is a discrete random variable. If support is a countable set, that means there's a way. If there's a way I can count all elements in the set, then this random variable x is called a discrete random variable. Next, let me introduce probability function. A probability function sometimes is called probability mass function. A probability function sometimes is called probability mass function. Let x be a random variable, be a discrete random variable. Let x be a discrete random variable. The probability function of x sometimes it's right PF. PF represents probability function. The probability function of x is defined as probability function of f is defined as f of x equal to probability that x equal to x. Probability function of x is defined as f of x equal to probability of x equal to x. This x is random variable. It represents some. We can plug in some value. We can plug in some values for this x. This x and this x, they are lowercase x. We can plug in some values for this x, and this is capital X. This x represents random variables. This x represents random variable. Those two x are lowercase x. We can plug in values for this lowercase x, but this x is capital X. It represents random variables. We cannot plug in values for random variable. This x stays the same. For these two x, we can plug in different values for these two x. Note, since f of x represents probability function of x, the probability is always between 0 and 1. The probability f of x represents probability that s equal to x. So probability is always between 0 and 1. And the sum of total probability, the sum of all x in the support f of x must be 1. That means the total probability must be 1. If we add all probability together, it must be 1. So those are two properties of probability function. Next, in example 1 and 2. Find their probability function. Find the probability functions of x. In example 1 and 2, find the probability functions of x. In example 1, support of x is from 2, 3, 4, 5 up to 12. So to find probability function, find the support first. Then find the probability for each x in the support. Find the probability for each value in the support. Next, find the probabilities for each value in the support. What's f of 2? F of 2 is probability that s equal to 2. In example 1, x represents the sum of the dice. If the sum of dice is 2, there's only one outcome. That's 1 over 1 out of 36. What's f of 3? F of 3 is probability that s equal to 3. If the sum of dice is 3, it could be either 1, 2 or 2, 1. For these two outcomes, s is 3. For these two outcomes, s is 3. So that's 2 out of 36. What's f of 4? F of 4 is probability that s equal to 4. F of 4 is probability that s equal to 4. S represents the sum of the dice. S equal to 4. We have 1, 3, 2, 2, 2. And 3, 1. For these three outcomes here, x is 4. X represents the sum of the dice. For these three outcomes here, x is 4. And that's 3 out of 36. F of 5. F of 5 is probability that x equal to 5. Probability that s equal to 5. For this, x represents sum. So 1, 4, 2, 3, 3, 2, 4, 1. For this 4 outcome, s is 5. For this 4 outcome, s is 5. That's 4 out of 36. What's f of 6? F of 6 is probability that s equal to 6. S equal to 6. X means the sum of the dice. We have 1, 5. For 2, 4, s is also 6. For 3, 3, s is 6. For 4, 2, s is 6. For 5, 1, s is 6. That's 1, 2, 3, 4, 5. 5 outcomes. 5 outcomes out of 36. F of 7. That's probability that x equal to 7. X represents the sum of the dice. X represents the sum of the dice. So 1, 6 is 7, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. For this outcome here, x is 7. That's 1, 2, 3, 4, 5, 6. 6 outcome out of 36. For f of a, that's probability that s equal to a. 2 plus 6 is a. 3 plus 4 is a. 4 plus 4 is a. 5 plus 3 is a. 6 plus 2 is a. We have 1, 2, 3, 4, 5. 5 outcome out of 36. F of 9. F of 9 is probability that s equal to 9. F of 9 is probability that s equal to 9. We know 3 plus 6 is 9. X represents the sum of the two dice. 3 plus 6 is 9. 4 plus 4 is 9. 5 plus 4 is 9. 6 plus 3 is 9. We have 1, 2, 3, 4. 4 outcomes. 4 outcomes out of 36. F of 10. That's probability that s equal to 10. X represents the sum of the dice. 4 plus 6 is 10. 5 plus 4 is 10. 6 plus 4 is 10. We have 1, 2, 3, 3 outcomes. 3 out of 36. F of 11. Probability s equal to 11. We know 5 plus 6 is 11. And 6 plus 4 is 11. We have 2 outcomes out of 36. F of 12. F of 12. We know 6 plus 6 is 12. So there's only 1 outcome out of 36. So first step, find the support. Then find the probability of all values in the support. Find support first, then find f of every values in the support. Then run the probability function. F of x equal to 1 over 36 if x equal to, this is lowercase x, f of x equal to 1 over 36 if x equal to 2 or 12. F of x equal to 2 over 36 if s equal to 3 or 11. F of s equal to 3 over 36 if s equal to 4 or 10. F of s equal to 4 over 36 if s equal to 5 or 9. F of s equal to 5 over 36 if s equal to 6 or 8. F of s equal to 6 over 36 if s equal to 7, and f of s equal to 0 otherwise. For all other values, f of s is 0. For all other x values, for example, when s is 1, when s is 0, when s is 100, f of s is always 0. So f of s is 0 otherwise, other than this value, f of s is 0. This is the probability function of x in example 1. This is the probability function of x in example 1. Next, let's try to find probability function of x in example 2. So first of all, find the support. In order to find the probability function, find support first. Support of x represents the set of all possible value of x. The set of all possible value of x. In example 2, x represents the number of heads. X represents the number of heads. We may have 0 head, 1 head, 2 head, 3 head, at most 4 heads. So support of x is 0, 1, 2, 3, 4. Next, we try to find probability for each value here. Try to find f of each value here. What's f of 0? F of 0 is probability that x equal to 0. Find a value for find f of each value here. F of 0 is probability that x equal to 0. Let me write it over. X represents the number of heads. For this outcome here, s is 0. So that's 1 out of 16. For this outcome here, s is 0. That's 1 out of 16. Probability that s equals 0 is 1 out of 16. What's f of 1? What's f of 1? F of 1 is probability that s equal to 1. x represents the number of heads. Here, for this outcome, s is 1. For this outcome here, s is 1. For this outcome here, s is 1. For this outcome here, s is 1. We have 1, 2, 3, 4. For these 4 outcomes, s is 1. That's 4 out of 16. f of 2 represents probability that s equal to 2. S equal to 2, we have 2, that means s represents number of heads, that means 2 heads in the sample space. This sample point has s equal to 2. There are 2 heads here. This sample point has s equal to 2. This one s equal to 2. This one s equal to 2. This one s equal to 2. And this one s equal to 2. We have 1, 2, 3, 4, 5, 6. 6 sample point has s equal to 2. X represents number of heads. Here, 6 sample point has s equal to 2. So probability s equal to 2 is 6 out of 16. F of 3. That's probability that s equal to 3. That's probability that s equal to 3. X represents number of heads. Here, for this outcome here, s is 3. For this outcome here, s is 3. For this outcome here, s is 3. And for this outcome here, s is 3. We have 1, 2, 3, 4. 4 outcomes out of 16. 4 out of 16. That's probability s equal to 3. Then f of 4. That's probability s equal to 4. That's probability s equal to 4. X represents the number of heads. Only this one has s equal to 4. This is 1 out of 16. Then, if we want to check the answer, we add this up, we must get 1. If we want to check the answer, add this up, we must get 1. Same thing in the previous problem. If we add this up, we must get 1. To check the answer, if we add this up, we must get 1. So for this problem, if we add this up, if we want to check the answer, add them up, we must get 1. 1 plus 4 is 5. 5 plus 6 is 11. 11 plus 4 is 15. 15 plus 1 is 16. 16 over 16 is 1. So the total probability is 1. Now, probability function f of x can be written as f of s equal to 1 over 16 if s equal to 0 or 4. This is lowercase x. This is lowercase x equal to 4 over 16 if s equal to 1 or 3, equal to 6 over 16 if s is 2 and 0 otherwise. For all other x value, f of s is 0. For all other s value, f of s is 0. Next, let's try more examples. Let f of x be defined as f of -2 equal to 0.1, f of -1 equal to 0.2, f of 0 equal to 0.3, f of 1 equal to 0.15, f of 2 equal to 0.25, and f of x equal to 0 for all other x values. Is function f a probability function? Is f of x a probability function? Remember, for probability function, f of x represents probabilities. So every value must be between 0 and 1. There are two properties. F of x must be between 0 and 1. Because f of x represents probabilities, probability must be between 0 and 1. And also, the sum of total probability must be 1 for all x in the support. Check these two properties. F of x must be between 0 and 1 because f of x represents probability. Probability must be between 0 and 1. And the sum of total probability must be 1. The sum of total probability must be 1. So let's check. F of negative 2 is 0.1. That's between 0 and 1. So that's okay. F of negative 1 is 0.2. That's between 0 and 1. So that's okay. F of 0 is 0.3. 0.3 is between 0 and 1. That's okay. F of 1 is 0.15. 0.15 is between 0 and 1. That's okay. F of 2 is 0.25. That's between 0 and 1. That's okay. So next, check the sum of total probability. If we add them up, do we get 1? If we add them up, do we get 1? So the sum of all x in the support of x, f of x, that's f of negative 2 plus f of negative 1 plus f of 0 plus f of 1 plus f of 2. If we add them up, we get 0.1 plus 0.2 plus 0.3 plus 0.15 plus 0.25. If we add them up, we get 1. Since f of x is between 0 and 1 for all x, and the sum of total probability is 1. Since f of x is between 0 and 1, and the sum of total probability is 1, then f is a probability function. Next example. Let f of x be defined as f of x equal to x over 20, where for x equal to 2, 4, 6, 8, and f of x equal to 0 for all other x values. Is f of x a probability function? So check these two properties. f of x must be between 0 and 1. And the total probability in the support, for all x in the support, the total probability must be 1. Let's check the values. Let's check the values here. F of x is s over 20. When I plug in 2, 4, 6, 8, this is always positive. When I plug in 2, 4, 6, 8, this is always positive. And it's always less than 1 because the numerator is less than 20. Is this a probability function? We check the sum for all x in the support. The sum of all x in the support is f of 2 plus f of 4 plus f of 6 plus f of 8. F of 2 is 2 over 20. F of 4 is 4 over 20. F of 6 is 6 over 20. F of 8 is 8 over 20. If we add it up, we get 20 over 20, which is 1. So, since f of x is between 0 and 1 for all x, and the support, and the sum of all x in the support is 1, then f is a probability function. Then f is a probability function. Next example. Let f of x be defined as f of x equal to 1 over 2 to the power x for s equal to 1, 2, 3, and so on. For s equal to 1, 2, 3, and so on. Is f of x a probability function? So check two things. F of x must be between 0 and 1, and the sum of total x, the sum of total probability must be 1. The sum of f of x for all x in the support must be 1. So here 2 to the power x is always positive. 1 over a positive number is always positive. So, and the denominator is larger. When I plug in 1, 2, 3, 4, 5, the denominator is larger. So this number is between 0 and 1. F of x equal to 1 over 2 to the power x. This is always between 0 and 1. It always belongs to the interval from 0 to 1. Because denominator is always positive. 1 over a positive number is positive. And when I plug in 1, 2, 3, 4, 5, the denominator is larger than the numerator, so it's less than 1. So this number is always between 0 and 1. F of x is always between 0 and 1. Next, let's check the sum. The sum of all x in the support. The sum of all x in the support is the sum that x is from 1 to infinity. X from 1 to infinity. F of x is 1 over 2 to the power x. This is geometry theory. This is geometry theory. The sum of geometry theory is the first term over 1 minus the common ratio. If this geometry theory converges because common ratio is half, it converges. Common ratio is half is less than 1, it converges. So the sum for convergence geometry theory is the first term over 1 minus the common ratio. For the first term, you plug in 1. 1 over 2 to the power 1 is 1. 1 over 2 to the power 1 is 1 half. 1 over 2 to the power 1 is a half. That's the first term over 1 minus the common ratio. Common ratio is half. Then simplify. A half over a half is 1. Since f of x is between 0 and 1, and the sum of the support is 1, then f is a probability function. So f is a probability function. Next example. If f of x equal to cx squared for x equal to 1, 2, 3 is a probability function. What is the value of c? Assume f of x equal to 0 for all other x values. If f of x is a probability function, then what's the value of c? So we know that the sum of total probability must be 1. The sum of total probability must be 1. So let's find the sum of total probability first. The sum of all x, the sum of f of x for all x in the support is x is 1, 2, 3. That's f of 1 plus f of 2 plus f of 3. It must be 1. For f of 1, we plug in 1 for x. For f of 1, we plug in 1 for x. That's c times 1 squared. For f of 2, we plug in 2 for x. That's c times 2 squared. For f of 3, we plug in 3 for x. That's c times 3 squared equal to 1. 1 squared is 1, 2 squared is 4, 3 squared is 9. 1 plus 4 plus 9 is 13. We get 13c. So it's 14, it should be 14. 1 plus 4 plus 9 should be 14. I get 14c equal to 1. So c equal to 1 over 14. Then check. If I plug in 1 over 14 for c, f of x is always greater than 0. If I plug in 1 over 14 for c, f of x is always greater than 0. And 1 over 14 times 1 squared is less than 1. 1 over 14 times 2 squared is less than 1. 1 over 14 times 3 squared is less than 1. So here we check f of x is always between 0 and 1 if I plug in 1 over 14. So c is a valid value. So c is a valid value. C equal to 14 is valid. C equal to 14 is valid. That's the answer. Always check. For your answer here, probability function f of x must be between 0 and 1. If it's negative or more than 1, this is not a valid c value. Next example. In example 3, find each of the following probabilities. In example 3, find each of the following probabilities. Find probability that x is less than 0. Probability that x is less or equal to 0. probability that x is greater or equal to 1. So, first of all, let's find support of x first. In example 3, find support of x first. In example 3, find support of x first. In example 3, the possible value for x is -2, -1, 0, 1, 2. Support of x is -2, -1, 0, 1, 2. The rest is 0. It doesn't count. -2, -1, 0, 1, 2. That's the support. So probability that s less than 0. That's probability of -2 plus probability of -1. So that's probability that s equal to -2 plus probability that s equal to -1, which is f of -2 plus f of -1. F of -2 is 0.1. F of -1 is 0.2. So we get 0.1 plus 0.2, which is 0.3. Probability that x less or equal to 0. That's probability that s equal to -2 plus probability that s equal to -1 plus probability that s equal to 0. -2, 1, and 0. This is f of -2 plus f of -1 plus f of 0. F of -2 is 0.1. F of -1 is 0.2. F of 0 is 0.3. So we have 0.1 plus 0.2 plus 0.3, which is 0.6. Next, probability that s greater than or equal to 1. That's 1 and 2. Probability that s greater or equal to 1 is 1 and 2. That's probability that s equal to 1 plus probability that s equal to 2, which is f of 1 plus f of 2. F of 1 is 0.15. F of 2 is 0.25. So add them up. And so it's 0.4. Next example. In example 5, find each of the following probabilities. Find each of the following probabilities. Find probability that x less or equal to 3 and probability that x is greater or equal to 5. First step, find the support first. Find the support first. Support of x in example 5, support of x is 1, 2, 3, 4, 5 until infinity. 1, 2, 3, 4, 5 until infinity. That's the support of x. Probability that x is less or equal to 3. That's probability that s equal to 1. Probability that s equal to 2. Probability that s equal to 3. That's f of 1 plus f of 2 plus f of 3. Plugging 1, 2, 3 into the function. Plugging 1, 2, 3 into this function. It's 1 over 2 to the power 1, 1 over 2 to the power 2, and 1 over 2 to the power 3. Plugging 1, 2, 3 to the function. That's 1/2 plus 1/4 plus 1/8, which is 7 over 8. Next, what's the probability that s is greater than or equal to 5? There are too many terms. It could be 5, 6, 7, 8, 9, 10. There are too many terms. X probability that x greater or equal to 5. There are too many terms. X could be 5, 6, 7, 8, 9, 10 until infinity. There are too many terms. Think of the opposite, the complement. Probability that x is greater or equal to 5. The opposite is probability that x is less than 5. That will be a little easier. Probability that x is greater than 5. The opposite is x is less than 5. If x is less than 5, then x could be 1, 2, 3, 4. If s is less than 5, it could be 1, 2, 3, 4. That's f of 1 plus f of 2 plus f of 3 plus f of 4. Then plugging 1, 2, 3, 4 into the function. Plugging 1, 2, 3, 4 into this function, we get 1 over 2 to the power 1, power 2, power 3, and power 4. Plugging 1, 2, 3, 4 into the function, then adding up. Half plus 1, 4 plus 1, 8 plus 1, 16. That's 15 over 16. 1 minus 15 over 16 is 1 over 16.